Hello, my dear students. This is Math Doc. So during this session, I'm going to discuss about series relations. So first, I'm focused on sigma notations. Let's see what is sigma notations. So if you need to add some numbers with some pattern, then we can use sigma notations. That must have a pattern. That's the thing. So to compress that pattern, we can use sigma notations. Let's see what is that. Okay. Now you consider a sum like this u1, u2, u3, u4. It goes like that up to un. Here 1 to n sum. Usually we denote this one by Sn. Sn, sum of n number of terms from 1 to n. From 1 to n. Then we can compress this one using sigma notation. Here sigma, we start from I to n. Then say r equal 1 to n. Here general term you put ur. Here u1, u2, u3, u4. Here r term we say ur. R terms we say ur. That is equal general term. In terms of that general term, we can write sigma. Okay. Then r varies from 1 to n. That is sigma notation. So here we have some special properties. Now sigma r equal 1 to n constant. Here this is constant. We say that is k times n. Second one, sigma r equal 1 to n constant time ur. We can take constant outside. K sigma r equal 1 to n ur. Then third one, sigma r equal 1 to n ur plus vr, sum of two variables. Then you can split sigma. Then sigma r equal 1 to n ur plus sigma r equal 1 to n vr. Then ur is the general term. Ur is the general term. Okay, by this relation, you can compress a series. Okay, now let's move further. Now, if you need to prove these relations, we can do this way. So, first one proof, sigma, I'll take left hand side, r equal 1 to n k. So, that means sum of n number of constant terms. Here we write k plus k plus k plus k. Here name n number of terms. Therefore, you write it is k times n. Now that equal to right hand side. That's how we done first relation. Now let's move to second one. Second relation. Sigma, take left hand side. Sigma r equal 1 to n k times ur. So here you write a series k times u1, k times u2. It goes like that. So up to k times un, you need to put at least 3 dots here because we have a pattern now. Then you can write that way. Then you take k outside. Then u1, u2, u3 up to un sum. Don't forget to put at least 3 dot. Then instead of this sum, you write sigma r equal 1 to n ur. Now that equal to right hand side. That's how we prove second one. Here first relation, here second relation. Now let's move to third relation. Sigma left hand side, sigma r equal 1 to n ur plus vr. So you put R equal 1 first, then U1 plus U2, U1 plus V1, then U2 plus V2, then put 2, then it goes like that. Then last term will be Un plus Vn. So you put R equal 1 first, then R equal 2 second, then R equal 3 third. Likewise, you go up to n number of terms. Now take U terms together, then U1 plus U2 plus Un. Then take V terms together, V1 plus V2 plus Vn. Then you say, for this part, write sigma R equal 1 to n UR plus sigma R equal 1 to n VR. Likewise, for this part, you can put sigma separately. This also you can put sigma separately. That is the relation of sigma. Okay, this is general notation. Then for some series, we can use sigma. Let's do a few examples for how to write UR and how to write sigma notations. Let's go further. Okay, now take this and all. You consider 1 plus 2 plus 3 plus a series like that. So according to the pattern, we can write this on general term R up to some n number of terms. Then this is UR, then you can write sigma R equal 1 to n, UR mean now R. Here 1 to n. Then you consider another example, here first one, second one. 2, 4, 6, it goes like that up to 2n. Then according to this pattern, you can write here sigma R equal 1 to n. Here general term you write 2R. Here R term, no? Then put here 2R. That's how we write sigma. Then according to the pattern, you write R term. So if you know n term, then you can replace n by R, then that will be R term. Or if this is not given, you need to check the pattern, then you need to find what is R. Third one, here 1, 3, 5, 7, here 2n minus 1, here 1 to n sum, here we write sigma R equal 1 to n, here n term, then R term will be 2R minus 1, 2R minus 1. Then you remember, even numbers we can create by 2R, odd numbers we can create by 2R minus 1 and 2R plus 1. It goes like that. Then fourth one, 3, 5, 7, then 2n plus 1. Then here you write sigma R equal 1 to n, here 2R plus 1. Here this is R term, this is n term, this is first term. Then here you need to put R term, that must be R term. So this is the thing about sigma notations. So on you can get a compressed form of a series using sigma notation. So one important thing, so Sn we write sigma R equal 1 to n UR, we call sum of first n terms, sum of first n terms. Then similarly, if you put limit n goes to infinity Sn, so the other side we write sigma R equal 1 to infinity sum, here up to infinity UR. Here this is finite series, and this is infinite series. It has infinite number of terms. Here we can denote this one by S infinity. S infinity. Here we call infinite series. Infinite series. So this is the thing about sigma notations. So far we have identified what is sigma notation and how to write it and what are the properties of sigma. So that's all about sigma. Thank you for watching us.